September 2025. Duration is 2 hours and total is 100 marks. Then we are going to go through the first page, which is our instructions, then quickly dive into our multiple choice questions. So question one there is multiple choice questions. It reads, which one of the following represents 1 mole of a gas at STP, right? So first thing that we need to know is that what it means to say STP. So here we're talking about standard temperature and pressure. Standard temperature and pressure. Okay, so standard temperature and pressure like that. Okay, so now according to this, we know this 1 mole of any gas occupies a certain volume, right? In terms of what STP there, right? So according to this, if we can just like quickly go through our periodic table or the data sheet there, we are actually going to take note of the values that we are given there. For example, here we're given the molar gas volume of anything at STP there, right? So STP of a gas, which is your Vm there, is actually going to give you a value of 22,4 dm cube, right? So now to go back there to our formulas there, we are going to have the first one that says A there, which is your 22,4 dm cubed, and then the other one is 28, which is incorrect there. Then the next one is 32, which is also incorrect. And then this one is 44,8, which is also incorrect. So the only correct answer there is going to be A, which is equivalent to 22,4 dm cubed of Ar, which is your argon. Then to proceed to question 1.2 reads the number of atoms in one formula unit. So the number of atoms in one formula unit of copper 2 sulfate there, right? So now we need to know the number of atoms that are actually found here in copper sulfate, right? So in terms of this, we're going to look at this formula, which is CuSO4 like that. Therefore, it means here what we're having, we only have one copper. Then I'm going to say 1 plus, then also our sulfur, we only have 1. Then plus, how many oxygens do we have? We're having a total of 4. So if we add that, we're going to get a value of 6. So it means our correct answer there is going to be B. And then these others are incorrect. Then we're going to proceed to question 1.3, which reads, study the equation below. Study the equation below, and then this equation is the one that we're given there. Is 2H2 gas plus oxygen gas plus 2H2O gas like that. And then we're asked which one of the statements below is correct, right? So which one of the statement is correct regarding this equation? So they are saying the first one there, it reads two molecules of hydrogen gas react with one atom of oxygen gas to form two atoms of water vapor, right? So now according to this, the first part is going to be incorrect, right? Because here, what we are referring to is supposed to be moles, not molecules. We're referring to the moles. These are the coefficient for the number of moles, right? So here they were supposed to use moles instead of what? Molecules. Then number B reads actually reads 4 atoms of hydrogen gas react with 2 molecules of oxygen gas to form 2 moles of water vapor. Again, this part that says atoms there is incorrect, and then the second part also for molecules is incorrect, and then the last part there is the only part that is correct. So B is also incorrect. Then C reads 2 moles of hydrogen gas, which is true, reacts with 1 mole of oxygen gas, which is true, and then to form 2 moles of water vapor, which is also true. So it means our correct answer there is going to be option C. So the correct answer there is going to be our option C. Therefore, automatically this one is going to be incorrect because they are talking about what? Grams there. Then we are going to proceed to the next question, which is our 1.4. It reads there, which one of the following physical quantities is a vector? So we're looking for a vector. So remember, a vector is a physical quantity that has got both magnitude and direction. So this has got both magnitudes and direction. So a physical quantity that has got both magnitude and direction. like that. So that's what we are looking for. Then according to this, we know time is going to be a scalar quantity because it has got only magnitude. Then when it comes to velocity, yes, velocity is going to be a vector quantity because it has got both magnitude and direction, while speed is going to be a scalar. It has got magnitude only, and distance also has got magnitude only. So the only correct answer there is B, which refers to velocity. Then 1.5 there reads, a characteristic property of motion at constant acceleration is, right? So now we're looking at uh, a characteristic property of motion at constant acceleration is that, right? So now in terms of our acceleration, we know it's going to be what? Change in velocity per unit time there. Then in terms of this acceleration, remember by formula, your acceleration is equivalent to delta V all over delta T, which is the rate of change of what? Of velocity, right? So it means now we need to relate to an equation that actually relates to velocity, right? So this one, change in position per unit time, change in position there. We are talking about displacement. Therefore, this is incorrect. Then B, there is change in velocity per unit time, right? So change in velocity there per unit time. So therefore, it means our correct answer has to be B. Then C says there velocity remains constant for the duration of the motion, which is incorrect there. Then D there, if velocity remains constant for the duration of the motion, it means your acceleration is going to be what? To be zero there, right? Then D there also says change in position remains constant for the duration of the, so this is also incorrect. It means the object is not what? Moving there, right? Then after that, 1.6 reads, in the equation, delta x is equivalent to VI delta t plus half a delta t squared. The part that says half a delta t represents what? So that part there is supposed to represent our displacement, right? So it represents our displacement. So for 1.5, that part is going to be our displacement, 1.6, right? So now this is displacement due to acceleration. Basically, this is displacement due to acceleration. So it's displacement due to acceleration, due to acceleration, like that. So it means our correct answer there is going to be our displacement, which is letter A there. So this is our answer. Then these ones are going to be incorrect. Then we're going to proceed to question 1.7. So question 1.7 is there. Consider the following, the diagram showing the velocity of a cycle versus what? Versus time. Then what are you asked to do there? They're asking which one of the acceleration versus time graph best describes the motion of the cyclist, right? So now I'm going to like split these parts. Let's say this is the first part there. I'm gonna call it A, and then this part there is B, and then this one is C, right? Oh, let me just like do it like this. Let me just like use letters A, B. Okay, let me just change color there. I'm going to say from A to B, then B, C, as well as D, right? So I'm going to have those three different parts, right? So now I'm going to say from A to B, what is happening? What is happening in terms of A to B? Let me just like label this graph so that it makes it easier. Let's assume this is our time there. 1, 2, 3, 4, 5, 6, 7, 8, and 9, continues like that, 10. And then here again, I'm going to use maybe let's say 2, 4, 6, 8, 10, like that. So these are just hypothetical values, right? So in terms of this here, AB, I want to calculate my acceleration, right? So remember your acceleration there in meters per square second, right? So it means now in terms of my acceleration, I'm going to say my A is equivalent to delta V all over delta T. Remember, it's change in velocity over change in what? In time. So in terms of this, what's my velocity there? Initially, I started at 0 between A and B, from 0 to 4, right? So it means my VF there is going to be 4 minus my initial, which is 0. And then my time there, I started at what? At 0, and then I'm at 2. Therefore, it's same as 2 minus 0. Therefore, I'm going to get an acceleration of 1 meters. I'm going to get a value of 2 into 4 there. I'm going to get a value of 2 meters per square second, right? So 2 meters per square second. Then after that, now I'm going to look at the velocity again between B and C, right? So I'm going to say B to C. What's happening? B to C there, I'm going to say my acceleration is equivalent to delta V all over delta T. Therefore, in terms of this, what's my acceleration, my velocity there? Can you see it's actually constant? So if we're having a constant velocity here, it means our acceleration automatically is going to be zero, because we're going to say 4 minus 4 all over, then the time from 2 to 6 is going to be 4, right? So at the top there, you're going to get a value of what? 0 divided by 4. So this is now what? Undefined. Therefore, B there, it means now we're having a constant velocity, a constant acceleration, a constant velocity. Therefore, we're going to have an acceleration of 0. So the answer there is 0 meters per square second, right? Then between C and D, what is happening between C and D? Again, in terms of my acceleration, so my acceleration is changing velocity all over changing time. Therefore, I'm going to say my velocity final there, according to this, is at 8 there. So I'm going to say 8 minus there. Then where did I start? I started at what? At 4 there, right? So all over 4 there, then divided by the time there. So the time we started at 6, now we're at 9. So 9 minus 6 is equivalent to what? To a 3. Therefore, I'm going to have a 4 all over 3. Therefore, I'm going to get a value of what? So if I say 4 divided by 3, therefore divided by 3, I'm going to get a value of 1,33, right? So it means my answer there is 1,33 meters per square second, right? So now we're asked in terms of the graphs, right? So in terms of the graphs, it means here we're having a velocity of like 2, then from B to C is going to be 0, then we're actually going to have a value of what? 1.33. So we're looking for a graph that is going to be like this, right? So we're going to have an acceleration there, let's assume of 2, then after that, after how many seconds? It means after 2 seconds there. So we're having here, let's say this is our origin there, our starting point, and then this is our time in seconds, right? Therefore, this is our acceleration there. So this is our acceleration in meters per square second. So it means we started moving there at 2 for a period of how many seconds there? For a period of 2 seconds, right? Then after that, now let me just like change color so that you can see. Then between B and C there, take note, is actually constant for how many seconds? Until what? 6 seconds there. Then after that, what happens to our velocity? It actually what? Increases. Therefore, acceleration changes from 0 to 1,33. So it means this one is going to be a bit below than that one, right? So let me just like increase maybe the height of the other one so that there can be a difference between these two. So at first it means I was moving at what? At 2. Then the second one is going to be what? To be low. So we're looking for a graph that is going to look like this. So according to this analysis, you can see they were having our A. It means my A there, my A to B is actually going to be bigger. Can you see? And then the other one is going to be lesser there. So it means our correct answer there is going to be option B. Therefore, we proceed to the next question, which reads, these others are incorrect because here these velocities are equal. If we can look at the acceleration there, so the acceleration is actually equal there, but according to the information that we're given, it was not what? Equal. So now we proceed to the structured questions, which is question 2 there. So question 2 reads, sodium thiosulfate, which is this Na2S2O3, reacts with 400 cubic centimeters of hydrochloric acid solution, then which is your HCl there, of concentration 0,15 mole per dm cubed, according to the following unbalanced equation, right? So this equation is unbalanced, right? So now they are asking us to rewrite the equation as a balanced equation, right? So the first thing, of course, we're supposed to balance this equation, right? So by the look of things there, we're going to start by looking at maybe sodium, which is our Na, right? So if we look at Na on this other side, right, you can see that your Na is got 1, and then this side you are having, I mean, 2 Nas, right? Therefore, we're going to say, let me just like rewrite this equation there at the bottom. So I'm having Na2 S2O3, then I will for now leave out those stage symbols and all. So HCl there to give me sodium chloride. So I'm going to space there, and then NaCl, then plus my sulfur again, plus my sulfur, then plus my SO2, then but the last one is going to be plus H2O, like that. Okay, so now let's look at our sodium there. If we can look at our sodium on our left there, we're having two of them, but on my right there, I'm only having one. Therefore, it means now I should actually multiply by a coefficient of what? Of 2, right? So if you can take note, if I multiply this Na by a coefficient of 2, this 2 is also going to affect my Cl. So if my Cl is now affected, it means now this side I'm also going to correct, because now the number of chlorines are no longer what? Equal. So I'm going to put a coefficient of 2. Therefore, if now I'm having a coefficient of 2, you can see on my left there, I'm having how many hydrogens? Two hydrogens. And also on my right there, I'm also having two hydrogens. So it means now the hydrogens are balanced, right? Then if I look at sulfur there, I'm having two sulfurs. And then if I can get this side, I'm having the first one and the second one. It means my sulfur is balanced. Then oxygen, I'm having three here. And then here I'm having two plus one, and then which is three there. So it means now my balanced equation is going to look like that. So that's the balanced equation that they are looking for, right? So now then we proceed to question 2.2, which says calculate the. So we're asked to calculate the number of moles of HCl, right? So we're looking for the number of moles of HCl added to sodium thiosulfate, right? So in terms of this, now we're actually going to say, what are we given there according to this data? This is the volume, right? So 400 there is going to be the volume. Let me just say data on this side there. This is the data that we're having there. We're having a volume which is equivalent to 400 cubic centimeters. Then we're also going to have a concentration, which is your C there, of 0.15, right? Mole dm cubed, right? Mole per dm cubed. Then the final one there, we are going to have our n, which are our number of moles, right? So these are the ones that are in question, right? So this is the formula that you're going to manipulate according to the data that you're given, right? So we're going to say our concentration there. Let me just like scroll a bit. So concentration according to the formula, concentration, right? So we're asked in terms of HCl, I'm going to say bracket HCl there. Concentration of HCl, concentration is equivalent to number of moles all over the volume, right? So this is equivalent to the concentration that I'm given there is 0.15. So 0.15 is equivalent to N that I'm looking for. But take note of this volume there that is given, right? So this volume here is in cubic centimeters, right? But the units of measurement should be in dm cubed, right? So for me to convert that 400 to dm cubed, I'm going to say 400 divided by 1,000, right? So if I divide there, I'm going to get a value of 0.4. So 400 divided by 1,000 is equivalent to 0.4. Then we are going to proceed to say all over 0.4. Therefore, my number of moles of HCl there is equivalent to, if I multiply, I'm going to say 0.15 multiplied by 0.4, right? So if I do the math there, I'm going to get a value of what? 0.15 multiplied by 0.4. Therefore, our answer is going to be 0.06 moles, right? So this is the final answer, which is 0.06 moles, like that. Okay, then we're going to proceed to question 2.2.2. So it says here the volume of sulfur dioxide, gas at STP that will be formed, right? So we're going to go back to the first part there that says calculate the volume of the sulfur dioxide at STP that will be formed there, right? So now according to this, we're going to say the number of moles that are actually going to be formed there. We do not have our H of sulfur dioxide. We do not have the volume of what? Sulfur dioxide, and we do not have the number of moles of sulfur dioxide, right? So now we are actually going to use the mole ratio according to this, right? So remember, we were able to calculate the number of moles of HCl. Therefore, we're going to focus on HCl versus our sulfur dioxide, right? Then formulate a mole ratio there, right? So I'm going to say here, according to this, I'm going to say HCl versus hydrochloric acid versus my sulfur dioxide, which is my SO2, like that. Then according to that balanced equation that we're having there, we say the ratio there, the mole ratio is 2 is to 1, right? So here we're having a coefficient of 2. Let me just change color to highlight there. So we're having a coefficient of 2, while list here is just nothing there. Therefore, it means we're having a 1. Therefore, I'm going to say here HCl. Therefore, I'm going to say HCl is 2 is to 1, right? Then after that, now we are going to look at the number of moles that we have, that the ones that we calculated for HCl, we calculated a value of what? 0.06. Therefore, I'm going to say on this side there, I'm supposed to be having 0.06 moles. Therefore, on this side, I'm going to put an X, right? So unknown there. So for me to get the answer of this one, we know the ratio is 2 is to 1. It means this one is supposed to be half of that. Therefore, it means now I'm going to say 2 all over 1 all over 2 multiplied by 0.06, right? So if I do the math there, I'm supposed to get a value of 0.03 moles, right? So it means these are the moles of what? Of sulfur dioxide. So SO2 is equivalent to this what? Number of what? Of moles. Then after the mole ratio, then now I can calculate the number of moles of I can calculate the volume of this sulfur dioxide. Remember, we asked in terms of what? The volume of sulfur dioxide. Therefore, I'm going to say now our N, according to the formula N, then I'm going to say SO2 to be specific so that you can see I'm calculating the number of moles of what? Of sulfur dioxide there. So V all over Vm, right? But in terms of this, we already have the number of moles. Therefore, I'm going to substitute where the number of moles as 0.03 is equivalent to V, which is the V that you are looking for. But here again, here we are told this thing happens at what? At STP, right? And at STP, we know the molar gas volume is equivalent to what? To 22.4 there. So let me just circle that 22.4. This is what we're having at 22.4. If I can just rotate real quick there so that you can see this is the 22.4 that we're looking for. Therefore, I'm going to say there all over 22.4, right? So 22.4, that's my value of Tm. So I'm going to say the volume there that is produced of sulfur dioxide is equivalent to 0.03, and then I multiply by 22.4, right? So if we do the math there, we are supposed to get a value of what? So I'm going to say 0.03 multiplied by 22.4. So our final answer there is going to be 0.672. So it's going to be 0.672, right? So it's the volume there. Therefore, I'm supposed to say in what? In dm cubed. Then after that, it means we are done with question 2.2. Then we're proceeding to question 2.2.3. So we are asked to calculate the concentration of sodium chloride, right? So your sodium chloride, this is your sodium chloride, which is your NaCl there. If I can highlight there, so this is the NaCl that you're looking for there. So it's a bit clumsy. Let me just erase there. So in NaCl, that's the one that you're looking for in terms of its concentration, right? What are we also given there? In 250 cubic centimeters of the solution, right? So this means this is our volume, right? So now for us to calculate this one, again, we're going to use the mole ratio from the balanced equation, right? So we're going to compare our HCl, since is the first thing that we're able to calculate is number of what? Of moles. So I'm going to use this HCl versus my sodium chloride. Can you see it's 2 HCl versus 2 NaCl? Therefore, I'm going to come back here and say there I'm having let me just split this page into two like that. Then this is now question what? This is question 2.2.3. So I'm going to say 2.3.2.2.3. Therefore, the ratio according to this, I'm supposed to compare HCl versus my sodium chloride, right? So NaCl, right? So according to our coefficients there, we agree this is 2 is to 2. Therefore, I'm going to say the ratio there is 2 is to 2, right? So if you can simplify this one, so it means this one is the same as 1 is to 1, right? Again, remember our number of moles for HCl, we already calculated them to be 0.06, right? So it means here, since the mole ratio is 1:1, it means this side also I'm going to get a value of at 0.06, right? So it means now the number of moles of NaCl is going to be 0.06, right? Then to go back again, they say they want us to calculate the concentration of sodium chloride. Therefore, I'm going to say, according to this formula, concentration of NaCl is equivalent to the number of moles all over the volume, right? So now in terms of this, we do not have the concentration. Therefore, I'm going to proceed to say C is equivalent to the number of moles I'm given there is 0.06, right? All over the volume, right? So if we can look at this volume there, again, is given in what? In cubic centimeters. Therefore, we are supposed to convert to dm cubed, right? So on this side, so I'm going to say 250 divided by 1,000 there, right? So if we can convert that one, 250 divided by 1,000, we're going to get a value of what? 0.25, right? So this is now in dm cubed. Therefore, I'm going to divide by that value there, which is 0.25. Therefore, if I can say 0.06, 0.06 divided by 0.25, 0.25, I'm getting a value of what? 0.24. So this is now in what? In mole per dm cube. So it's 0.24. I'm going to say mole per dm cube because this is what? This is our concentration then. So we are done with question 2.2.3. Then we're actually going to proceed to the next question, which is now our 2.3. They're saying the reaction can be used to extract sulfur. So this reaction can be used to extract sulfur from sulfur thiosulfate, right? Then determine the mass of sodium thiosulfate required to form 50 grams of this sulfur, right? So in terms of that, now we're supposed to go back again and say start by calculating the number of what? Of moles of sulfur, right? So why the number of moles of sulfur? Because there we have got the mass and then we have got the sulfur of sulfur. Therefore, we can calculate the number of moles from the formula N is equivalent to M all over M. So we're going to focus first on sulfur. Therefore, let me just like go down there. So we're going to say in terms of sulfur, allow me to underline there. So the number of moles of sulfur is equivalent to M all over M, right? So this is equivalent to, according to the mass that is given there, we're told sulfur 50 grams of it. Therefore, I'm going to say 50 all over. Then from our periodic table there, if I can just like scroll down a bit there for our periodic table, you find that our sulfur there is 32, right? So I'm going to use a value of what? Of 32 there. So it means 50 divided by 32. So if I can say 50 divided by 32, I'm going to get a 50 divided by 32 is equivalent to 1.56. 1.56. So I'm going to get a value of 1.15625 moles, right? So these are the number of moles that I'm getting, right? So now I'm going to go back to the ratio again, to the ratio. Now, what am I comparing there? The ratio between my sulfur and my sodium thiosulfate there, right? So in terms of this there, if I can just like scroll up there, right? So my sodium and my sodium thiosulfate, right? So it means now in terms of this, what are we having in terms of this formula? The reaction can be used to extract sulfur from sodium thiosulfate, right? So if I can just like move on there at the top, right? So it means here, what am I having? My sodium thiosulfate there, it means the mole ratio there is actually, I'm having a 1 there, and then versus the 1 for sulfur there, you can see also I'm having only 1 sulfur. So I can just like come back there and write the mole ratio. So according to the ratio there, sulfur there is 1, sodium versus sodium thiosulfate, which is our Na2S2O3, right? All over. So the 1:1, right? So that's the mole ratio then. If we're having the mole ratio like that, then how many moles did we actually calculate for sulfur there at the top there? We got a value of 156, 1.56. So it's 1.56 2 or 5. So is 2 on this side there, 1.5625, right? So they are actually going to be equal because the mole ratio there is 1:1, right? So then after that, now we can go ahead and calculate the number of moles of Na2S2O3, right, is equivalent to M all over M, right? Therefore, the number of moles there we already have. Therefore, it's going to be 1,5625 is equivalent to. So we're asked in terms of the what of the mass of they're saying determine the mass of the sodium thiosulfate, right? So this is the mass that you're looking for, which is our M there, right? So I'm going to say small letter M there at the top, which is the mass. Then I'm going to go back and expand this sodium thiosulfate there. So our sodium there is got a mass of what? 23. So relative atomic mass for sodium is going to be 23, then multiplied by 2. Then I'm going to say plus there. Then I also have my sulfur, which is 32, and I'm having two of them. Therefore, I'm going to say 32 times 2, then plus, then the last one there is going to be my oxygen, which is 16 times 3, like that. So this is what we are having in terms of this. Therefore, we are going to proceed to say the 1,56825 is equivalent to M all over. So if we were to do the math there, I'm getting a value of 23 times 2 plus 32 by 2 plus 16 by 3. Okay, I'm getting a value of 158, right? So it's going to be 158. Therefore, my M there in terms of this, to make M the separate formula, I must cross multiply. So it's going to be 1,5625. Then I multiply by 158, right? So to get my mass there, right? So I'm going to say my 158, 158 multiplied by 1,5625, which is equivalent to 246, 875. So it's going to be 286. So it's going to be, so my M there is equivalent to 286, 246, sorry, 246 there, not 86, 246, 246, 246, 875. So 875 grams. So this is how we calculate our question number 2.3 there, right? Then I'm going to proceed to question number 3. Then question number 3 there reads an unknown organic compound is a formula of, so this is the formula that you're given, CXHYO and then Z. Then we're given the molar mass of this compound is 88 grams per mole. So we're given the molar mass that is 88 grams per mole. Then we are asked to determine or to define the term empirical formula, right? So empirical formula is defined as the simplest whole number ratio. So this is the simplest whole number ratio, simplest whole number ratio, number simplest whole number ratio of atoms in a compound, of atoms in a compound like that. So this is what you are having in terms of the empirical formula. Then I'm going to proceed to 3.2, which says 2 grams of the sample of 2 grams sample of this compound contains, so we have got 1,09 grams of carbon and 0,18 grams of what, of hydrogen. Then we are asked to calculate the mass of what, of the oxygen, right? So remember, we are having this original formula, the one that is actually unknown there. So it means now this whole sample, what does it contain? It contains 2 grams, right? So for me to get the answer there, I'm going to say my 2. So the original mass of everything there is 2. Then I'm going to subtract the 1 for carbon there, minus 1,09, right? And then also subtract the 1 for hydrogen, which is 0,18 minus 0,18. Therefore, I'm going to get a value of, if I can just say 2 minus 1,09 minus 0,18. So I'm getting a value of 0,73. So it's equivalent to 0,73. So my answer there is 0,73 grams, right? So it means now this is the mass of my oxygen. Therefore, oxygen is 0.73 grams. Then 3.2.2, you are asked to determine the empirical formula. Determine the empirical formula of this formula, right? So now I'm going to need space to work this one out. I'm going to use a table. So my table there is going to contain carbon, hydrogen, and oxygen, right? I'm going to start with carbon, followed by my hydrogens, then lastly my oxygens, right? So now in terms of this, we were given their masses and the other one for oxygen, though we had to calculate it. So this is what we are having in terms of our values there. So I'm going to just like take this value. Carbon is 1.09. So my carbon there is going to be 1.09. Then my hydrogen in terms of this is 0.18. So hydrogen 0.18, 0.18. And then the last one that we calculated was 0.73. If I'm not mistaken, let me just confirm. Yes, 0.73, right? So for us to calculate this, we need to also to get the number of moles, right? M all over M there. That's the number of moles, right? So it means now the relative atomic mass for carbon is carbon 12. Then my hydrogen is equivalent to 1. Then my oxygen there is 16, right? So if we're to do our math there, I'm going to say 1.09. 1.09 divided by 12 there. I'm getting a value of 0.09. I'm going to say 0.0908. I will end there. And then the next one, any number you divide by 1, it retains its value. Therefore, now the next one is going to be 0.73. So 0.73, 0.73 divided by 16, because oxygen is 16 there. Then I'm going to get a value of 0.045, right? So I'm going to say 0.045 like that, right? It continues 6 and stuff, right? So now in terms of this, now this is what I'm having in terms of my moles, right? So the next one, I'm supposed what to divide by the smallest number of moles, divide by the smallest, right? So the smallest what number of moles, right? So I'm going to look at these values. Therefore, the smallest there is going to be 0.045, right? So I'm going to take that one as it is 0.0456 all over like 0.0456, right? So I'm going to also divide by the same value here, because 0.0456 is the one that is the smallest, 0.0456, right? And then the last one there is going to be 0.09, so it's 0.0908, right? So all over 0.0456 like that, right? So if I'm to do my math there, I'm going to get a value of 1. Therefore, I'm going to proceed to 0.18 divided by 0.0456. I'm getting a value of ST there, which is 3.94. So if I round it off there, I'm going to get a value of 4, right? Then I proceed to the last one there, which is my carbon. So I'm going to start again with 0.0908 there, 0.0908 divided by 0.0456, right? So I'm getting a value of 1.99. So if I can round it off, I'm going to get a value of 2, right? So this is the after dividing by the smallest values, these are the answers that I'm getting, right? Therefore, now in terms of my carbon there, it means I'm having how many carbons? 2 carbons. Then in terms of my hydrogen there, I'm having 4 hydrogens. Then my oxygen is only 1. Therefore, I'm going to retain that value as it is. So this is our empirical formula. Then we are actually going to proceed to the next question. So our next question is based on let's see there. So our next question there is based on determine the molecular formula. We've been asked to determine the molecular formula. So we're asked to determine the molecular formula of this compound, right? So it means here our molecular formula there, what are we given in terms of the mass there is 88, right? So we're given the value of what 88 grams per mole. So this is the molar mass that is actually given there. Then after that, now we're going to say there, let me just like split that one there so that we can have some space to write. Then I'm going to say now from the this molar mass of So I'm going to start with the molar mass of C2H4. Oh, like that, right? Is equivalent to, I'm going to say my carbon is got a mass of 12 multiplied by 2 because I'm having two carbons there, plus my hydrogen there is got a relative atomic mass of 1 multiplied by 4. Then the last one there, I'm going to say plus oxygen, which is 16 multiplied by 1, right? So if we were to do our math there, 2 times 12 is 24, 24 plus 4. 28 plus 16, getting a value of what is it 44 there, right? So I'm going to get a value of what 44 grams per mole, right? So it's 44 grams per mole, right? So this is what I'm getting. Then after that, now from this value that you're given, we are already told this is 88, right? So I'm going to divide my 88 by 44, right, to get the ratio, right? So the ratio there is equivalent to 88 all over 44, right? So I'm going to get a value of what? Of 2, because 88 is 44 is the half of what? Of 88. Then after that, now what I'm going to do there is to take that formula that I already had at the top from the empirical formula. I'm going to say H4, then O, then I'm going to say bracket, then multiplied by what? By 2 there, right? Therefore, it means my answer there is going to be C, 2 times 4. 2 times 2 is going to be 4. Then H there, 4 times 2 is going to be 8. Then the oxygen there is going to be my O2, like that, right? So now we are done with question 3.2.3, right? So this was question 2.3.3.2.3, like that, right? So now to proceed to the next question there, which is now question 3.3, right? So from question 3.3 reads, formula of the hydrated carbonate of an unknown group metal, one metal, represented by X with the formula mass of 286 is given below, right? So this is the formula that is given below, right? So now it has got a formula mass of 286. Then they said, what is the general name for a substance in which water is not directly attached to uh, ion as indicated above, right? So what is the general name of for a substance in which water is not directly attached, so it's not directly attached to the metal ion as indicated above, right? So this is referred to as what? Water of crystallization, right? I'm going to say this is referred to as water of crystallization, right? So crystallization, like that. Okay. So then that's the answer that we're looking for. Then after that, now we are going to proceed to question 3.3.2, which says they determine by calculation, right? The unknown group 1 metal represented by X in the formula, right? So that's what we are looking for there. I'm going to now say, let's calculate what we are given in terms of this. So in terms of this, I'm going to say equate these two to that there, right? So it means here I'm having an X2, then CO3 there, then dot there, then 10 H2O is equivalent to that value there, the formula mass that you're given, 286, right? So in terms of this now, I'm going to say let's formulate that X there to be the subject of the formula, right? So for us to get this one as the subject of the formula there, I'm going to say there, how many x's do I have there? It's going to be what? 2 multiplied by x there. So it's going to be 2x, right? So 2 multiplied by x is going to be 2x, right? I'm going to add there plus, then bracket there. What am I having? I'm having my carbon, which is 12 there. So it's 12 multiplied by 1, also plus. Then I'm going to have my oxygen, which is 16 multiplied by 3, 16 by 3. And then after that, I'm going to say add again, right? So how many of these do I have there? I'm having 10 H2s, right? So it means 10 times 2. What am I going to get a value of 20, right? So it means, remember, hydrogen has got a relative atomic mass of 1. So it's going to be 10 multiplied by 2 there because we're having two hydrogens. Therefore, I'm going to say bracket 10 times 2. Then after that, I'm going to say plus. Therefore, we're also having our oxygen there. So our oxygen there is going to be multiplied by also by 10. Therefore, I'm going to say the relative atomic mass for oxygen is 16, then multiplied by 10. Therefore, this should be giving us an answer of 286, right? So just to retain these values, this is going to be 12. Then I'm going to say plus again 2x plus 12 plus 16 times 3 it's going to be a value of 48 there. So 48, then I'm going to say plus. Then after that, 10 times 2 is equivalent to 20. Then plus 16 times 10, which is equivalent to 160, is equivalent to 286, right? So let's quickly do the math on our left there to see what you're going to get. So it's 12 plus 48 plus 20 plus 160. So it gives us a value of 240. So it's going to be 240. Therefore, I'm going to say 2x plus 240 is equivalent to 286, right? So now we're supposed to make x the separate formula. Therefore, I'm going to transpose there. So I'm having 286, then subtract the 240, right? So it means 286 minus 40. What do I get? So let's just say 286 there. I'm going to get a value of what? 46, right? So it means my answer there is 46. So 2x is equivalent to 46, right? So that's a 2 there. Therefore, after that, I'm supposed to make x the substitute formula. Therefore, I'm supposed to divide there. So it's 2, 2. Therefore, your x there. So x into 46 is going to be 2 into 4 is 2. So it's going to be 23, right? So this is the relative atomic mass that we're actually getting. Then after this now, we're going to refer to our periodic table to see where we can find our 23, right? So according to this, we can see there we're actually having our sodium, which is 23. So our answer there, it means our x there represents our sodium. So your x is equivalent to your sodium like that. So that's how we're supposed to attempt question 3.3.2. Then we're going to proceed to question 4, which is now the physics part. Then it reads there, Sam is training for a marathon. He jogs from his house to the mall for 25 minutes. So the period of time that he jogs there is 25 minutes. And then he returns back he turns back around and continues to jog straight to the park for 35 minutes. Then when he gets to the park, he sits down to rest, right? So it means that the park there. So according to this information there, he started from here. Where did he go to? He went to the mall. He jogged to the mall, right? Then according to the statement there, it says he then turns back around and jogs straight to the park, right? So he takes this part and then returns until he gets to the park there. So this is his final destination, or his final location was where? At the park like that. Okay. So now the first question is there. Define the term distance. So distance is actually defined as the total path taken, right? So this is more of like the total path taken, right? Total path taken, or the route that you actually took, right? So how much distance did you travel? So it's the total path that is actually what taken, right? Then I'm going to proceed to 4.2, which is there. Calculate the distance covered. Calculate the distance covered. So we're looking for the distance covered by Sam during his jogging session to the mall, from his house and then to the park. So it's more of like the total distance that he actually traveled there. So I'm going to say there, so my distance is equivalent to, according to this, allow me to write at the top there. So my distance is equivalent to, so he started from his home to the mall, and then they were given a value of what? 3,000. Therefore, I'm going to say 3,000. Then I'm going to say plus. Then if I look, then I was told he went back, right? So it means before he got to the park, he passed through his what? His home or his house, right? So from the mall to his house, then it's also again going to be the same distance, which is 3,000. Then after that, he passes his home, goes to the park, which is 1,200, right? So therefore, if we were to do our math there, I'm going to say 3 plus 3 is 6, so it's more of like 6,000 plus 1,200. So I'm going to get a value of 7,200 meters. So the total distance traveled there is 7,200 meters. So that's how we calculate the distance traveled. Then after that, we are asked to calculate the average speed. So we're asked to calculate his average speed for the entire jogging session, right? So what we need to take note of there is that how do we actually calculate our average speed, right? So it means there I can say from my DST there, I can automatically say my V is equivalent to distance over time, right? So d over change in what in time, right? So it means my distance that he actually traveled there, he traveled a total distance of 7,200 meters, right? All over the time, right? So now the total time that he took there, I'm going to add these times there, 35 plus 25, right? So 35 plus 25 there, if I can just like add here, 35 plus 25 is going to give me a value of how many minutes? 60 minutes, right? But remember, the units of measurement for time is in what? Is in minutes, right? Is in seconds. So I'm supposed to convert these minutes to seconds. Then how do I go about that one? I'm supposed to say 60 times 60 because an hour, this is equivalent to an hour there. So an hour is made out of how many minutes? 60 minutes. And then each minute is made out of how many seconds? 60 seconds, right? So I'm going to punch that as it is on my calculator there. I'm going to say 7,200 divided by 60 times 60. Therefore, I'm going to get a value of 2 there. So it means this velocity there is equivalent to 2 meters per second, right? So remember, your speed there is your scalar quantity. Therefore, there is no need for us to look for direction. Then we proceed to question 4.2.3, which says calculate the displacement of the entire jogging session, right? So in terms of displacement, remember your displacement is now a what? A vector quantity. So allow me to erase the top part there. So displacement is our vector quantity. So if it's a vector quantity, it means it has got what? Both magnitude and direction, right? So this is for point 2.3 like that. Okay, so now let me just like change color. Then this is equivalent to what are we looking for? We're looking for our displacement, which is same as what? Delta x. This is our displacement, right? So now I'll take to the right, going to the right or east there, right? As being what? Positive, right? So I'm just going to say positive there. East as being what? Positive, like that. Okay. So then after that, I'm going to say the first time that he took his jog there, he headed towards the east there, right? So and then he jogged for how many meters? So I'm going to say this is equivalent to 3,000. Then after that, he went back, right? So he passed his home. So it means now he's heading in the opposite direction. Therefore, I'm no longer going to use a positive, but I'm going to say plus, then minus 3,000 there, right? And then again minus, after that minus, how much distance there did he travel again? 1,200. So 1,200 like that, right? So if I can just like expand my bracket there, what am I going to get? A plus multiplied by a negative, I'm going to get a negative, right? So I can easily write it like that. Therefore, my answer is going to be 3,000 minus 3,000 is 0, then minus 1,200. So my answer is negative 1,200 meters, right? So remember, we chose to the right as positive or east as positive. Therefore, it means now we're getting a negative value. So it means now he's heading in the opposite direction. So my final answer there is going to be 1,200 meters to the west. To the west, or you can say to the left. Therefore, that's how we calculate our 4.2.3. Then I'm going to proceed to question 4.2.4, where we are asked to calculate the average velocity for the whole journey, for the whole jogging session, right? So for us to calculate this one, we're going to say 4.2.4 for average velocity. Remember, we use our displacement, right? So our displacement, we already calculated it to be 1,200 there. So allow me to change the color again, maybe to this one there. Then I'm going to say now, what am I having there in terms of my displacement, right? So remember, our displacement now is equivalent to, they're saying what, calculate the average velocity. Okay, so average velocity has to do with what? Displacement. So I'm going to say V is equivalent to delta x all over change in time, right? So now my displacement there, I already calculated it to be 1,200. Therefore, I'm going to say this is a 1,200, right? So remember, I was heading west. Therefore, I'm going to put that negative there all over the time that it took, right? So remember, it's going to take the same time there. So remember, we said 35 plus 25, right? So these are the times that we're having, 35 and 25. Therefore, if we added there, we got a value of what? Of 60 minutes. Therefore, for us to convert that 60 minutes to seconds, we're going to say 60 multiplied by 60. Therefore, now it means here I'm going to get a 1,200 divided by 60 times 60, which is equivalent to uh, uh, 1,200, all over 60 times 60. So I'm getting a value of 0.33 meters per second, right? So it's equivalent to a negative 0.33 meters per second, right? So now as my final answer, I can just say, since it's a negative value, so it means it's heading in the opposite direction, 0.33 meters per second. Where is it going now? It's no longer east, it's now what? To the west, right? So west, like that. That's how we actually go about that question. Then I'm going to proceed to question 4.3. So they're saying here, why are the speed in 4.2.2 greater than the velocity in 4.2.4? Okay, so in terms of this here, the differences that we actually have here is that speed is more of a scalar quantity. So we're going to talk about speed as being what? A scalar quantity. Then velocity as a vector quantity. So that's how we're actually going to answer this one. So speed is a scalar quantity. So it means here we added the total path length that has been traveled, whilst on this other end here we used our displacement, right, from start to the finish. So those are the differences there that actually make the difference in what? In terms of the velocity. Then I'm going to proceed to the next question that says there, that says there, uh it says 4.4. It says there, use a vector scale diagram and represent Sam's displacement from the time he jogged from his house to the mall until he stopped at the park to rest. Right? Use the vector scale diagram. So we're looking for a vector scale diagram there for him that he actually used to jog from his house until he got there. Right? Then after that, now it says here, uh all relevant information is all relevant information in the diagram. Use the following scale there that says 1 centimeter is to 1,000 meters, right? So we're supposed to use this scale there, right? So then now for us to draw this, we are going to say where did he start from? So I'm going to start where he started there. So he started from the house, right? So going to this direction, right? So he started from his home to the mall, right? So I'm going to say this is my first part there, from his house, okay, to to the mall, right? So I'm going to draw something like that there. So then after that, I'm going to say this is the first displacement there, right? So this is displacement number one. Displacement, remember, we represent it by delta x. This is the first displacement. Then after that, where did he go? He went back to the he passed his home to the park, right? So it means now this is the second displacement there. This is my delta x, which is number two, right? Then the final there, remember we calculated our resultant to be how many there? To be 1,200 meters to the what? To the west, right? So it means my line for the resultant is to go in that other direction. Therefore, I'm going to start my resultant here going to the left like that, right? So I'm going to get a value of what? 1,200. Therefore, I'm going to say this is my resultant, right? So this is my like that. So these are the values that we are going to have there. Then in terms of like this is the measurement. We already had a value of how many? So it means the one that says 1,200 meters there is going to be 1,2 centimeters, right? So the one that says there 1,200 centimeters is equivalent to 1.2, right? So then the one that is 3,000 meters, so 3,000 meters is going to be 3 centimeters, right? And then the other one means here we also got 3,000. Then the other one, which is our resultant there was, 1,200. Therefore, my 1,200 meters will be equal to 1,2 centimeters, 1,2 centimeters. So that is how we are supposed to draw this according to the scale that is given there. 1 centimeter is to 1,000 meters. Okay, so now we're actually going to proceed to the next question, which is question number 5. We're given the position time graph for a quad bike traveling north. So it's heading towards the north along a straight horizontal surface as shown below. The graph is not drawn to scale. Then the quad bike starts from rest and moves at a constant acceleration. So you started from rest and then you moved at a constant acceleration. So this is the graph that you are given. Then you are asked to define the term instantaneous velocity. So which is the rate of change of position, right? So there is defined as the rate of change in position. So this is my instantaneous what velocity, right? So then after that you are asked to calculate the instantaneous velocity. Calculate the instantaneous velocity of the quad bike at 6 seconds, right? So for us to calculate this one, we are going to say according to the formula, your v there, basically your v is equivalent to delta x all over delta t, like that. Then I'm going to say my v. Remember, if I'm to break this one further, it's the same as V is equivalent to X final minus X initial, right? So X final minus my X initial all over the time final. So it's more of like T final minus T initial, right? So this is equivalent to my X final there. It means my displacement, my position was where? At 36, right? So 36 minus where I started from, which is a 0 all over the time final. So my time final was 6 there. Then the initial where I started there, I started according to this for instantaneous velocity. It's going to be for 3 seconds right there. I'm going to have there. Then after that, I'm going same as 36 divided by 3. So I'm going to get a value of 12 meters per second, right? We were told this quad bike was heading in the direction of the north. So I'm going to say the direction remains the same as what? North there. Then I'm going to proceed to question 5.3. They're saying using equation of motion only, determine the magnitude of the quad bike's acceleration during the first 6 seconds, right? So according to this, I'm going to say my data there. So my data like that. Then what I'm going to have there is my delta t. According to this, my delta t is equivalent to, which is my time, is 6 seconds. Then after that, I'm going to have my delta x. My delta x is equivalent to the displacement there, which is the position is equivalent to 36, right? Then after that, I'm also going to have my initial velocity, my VI. I started at 0. Then after that, 0 meters per second. Then this is in meters. Then also I have my acceleration. So they are asking in terms of the acceleration. Therefore, I can say my acceleration is equivalent to unknown, right? So according to this information, if I can go to my data sheet, I'll find that I can use delta x is equivalent to VI delta t plus half a delta t squared, like that, right? So my delta x there already is my displacement, which is which is 36 meters, is equivalent to initial velocity, which is 0 multiplied by time, which is 6 seconds, then plus half my acceleration there, which is unknown. I'm going to say a, then my t there, my t is going to be 6 squared, like that, right? So if I'm to do my math there, my a is equivalent to, let's see, this one retains 0. So basically I'm having a 0 here. I can say 36 is equivalent to 0 plus half a6 squared, like that, right? So if I do my math correctly there, I'm going to get an acceleration. To make a the subtotal formula, I'm going to get a value of what? Mm, 36 half of squared there, like that. Yes, I'm going to get a value of 2 meters per square second, right? So it's 2 meters per square second, right? So this is the first option. You also had another option maybe of using a different equation. Or we could have said Vf squared is equivalent to Vi squared plus 2a delta x there. So same as Vf squared is equivalent to Vf squared, which is your final velocity, Vi squared plus 2a delta x, 2a delta x, like that. So it means my final velocity there is 12 according to our calculations there. It's going to be 12 there, 12 there at the top. So it's 12 squared. I'm getting this from that top part there is equivalent to, where did we start? We started at 0. Therefore, I'm going to say 0 squared, then plus 2 bracket my acceleration that I'm looking for, and then my displacement there was, 36, right? So if you are to manipulate this one there, you are supposed to get the same value there, which is more of 144 is equivalent to 0 plus 2 times a is 2a multiplied by 36, I think it's 72 there. So we're going to have a 72a. Therefore, we divide both sides by 72, 72. Therefore, let me see. 144 divided by 72 is equivalent to a value of 2. So I'm going to get the same answer, which is 2 meters per square second. So my acceleration is equivalent to 2 meters per square second, right? So there, if I was to include the direction, so it means you never change the direction, so to its original direction. Well, we told the direction there, so which is north, yeah. So I'm going to just say maybe to the north, so north, like that, north. But in terms of this, we're asked to calculate the magnitude only, right? So there, if we say 2 meters per square second, like that, you are going to be marked correctly. Then I'm going to proceed to question number 6, which says consider the following velocity time versus time graph for a Gautrain traveling from Centurion to Midrand in the Gauteng, right? So then after that, it reads here, how many times so we are having a velocity time graph like that, right? So your time there is given in minutes. Take note whenever we are calculating, because your time should always be in seconds there. Then says how many, 6.1 says how many times, right? So how many times does the train stop between, okay, so this is important, between Centurion and Midrand, right? So we're having the first point there. So it means this train started at point A, right? And then between B and C, what's happening there? There is constant velocity. It means constant velocity. There is no acceleration. Then it actually what? Slows down until 0, right? So there between 5 and 6 there, this is the first stop, right? So this is the first stop. Then actually it actually then goes from 6 until what? 20 for until 7 seconds there. It increases its velocity to 20 meters per second. Then between F and G there is also constant. Then it slows down there, and then it has its second what? Stop, right? So the belief is that that point there, this is where we're having our mid-run, right? So I'm going to say mid-run there. So this is mid-run there. So I'm actually going to say MID. Then where did we start there? We started at Centurion. I just say send there, right? So it means this is the first stop, and then this is the second stop. When we are stopping now at Midrand there, this is the final distance, destination, right? So where you are actually going to go, where you are headed, right? So here, but what we asked, it says between. So it means there are how many stops? We only have what? 2 stops. So our answer there is going to be 2 stops. So the train stops twice. Then 6.2 reads there, how long, how long, 2 stops, or can say how many times, I can say twice also, stops twice. So how long did the train take to move from point A to B? So how long did the train move from A to B, right? And then express your answer in seconds, right? So in terms of this, it means here from A to B, there is a period of 1 minute, right? So that 1 minute is equivalent to 60 seconds, like that. So that's our answer there. Then define the term acceleration in words. So this is defined as the rate of change of velocity, rate of change, or in what velocity, or of velocity there, right? So that's how we define our acceleration. Then 6.4 is there. Describe the motion of the train between these points from B to C, right? So let's look at B and C there, right? So B to C, we can see the velocity is not changing, right? So it's constant velocity. So we're going to say we're having constant velocity, constant velocity. So this is constant velocity. Then the next one that you're having there, we're going to say anything that you also have in terms of that there. Remember, whenever there is constant velocity, there is no acceleration. So no acceleration, or the second one, acceleration is zero. Acceleration is zero. Acceleration is zero. Okay, so then the second one, C and D, right? So between C and D, right? So you can see the velocity is decreasing, right? There is a decrease in velocity. So I can say decrease in velocity, or velocity is decreasing. So velocity is decreasing there between C and D. Velocity is decreasing. Then the second point there is going to be that in terms of acceleration, right? So there is constant acceleration, but in the opposite what direction. So acceleration is constant, but in the opposite direction. Constant in the opposite direction. So we're heading in the opposite direction then E and F, between E and F, the E and F, right? So also there's an increase in velocity. So between E and F, there is a velocity increase. So increase in velocity, there is increase in velocity, or velocity is increasing. Then also it means now you can also add there is what acceleration. There is acceleration. So acceleration. So acceleration again. So acceleration there, like that. Towards the, where is it going? Towards mid-range. So acceleration to what's mid-range, like that. So this is what you're having. Okay, so to proceed to question 6.5, it says calculate the acceleration of the train from point A to B, right? So acceleration from point A to point B, right? So for us to calculate that one, we're going to say your acceleration there between A and B, between A and B, right? Acceleration between A and B. So just to erase there, So your acceleration between A and B. So it's from here and there, right? So we're having acceleration from what? From 0 to 20 within a time of that, right? So remember, your acceleration there is equivalent to change in velocity, rate of change of what? Velocity all over delta t, right? So if we want to break it further, down further, we can say Vf minus my Vi all over your time, right? So it can be, if you want to break it again, you can say T final minus T initial. Therefore, this is equivalent to, so the final velocity was 20 there. Then you started way at 0, right? So 0 all over the time final there is a minute, right? So that 1 minute you can convert it to what? To seconds. So it means it's at 60 seconds. 60 minus the initial, you started 0. Therefore, our answer there is going to be 20 divided by 60, 20 divided by 60, which is equivalent to, so our answer there is 0, 0.33, right? So we're going to get an answer of 0, 0.33 meters per square second. Take note of the unit of what? Of measurement there, right? So that's what we are having there for that 6.5. Then 6.6 asks us to plot an acceleration on the on dependent y-axis versus time on independent x-axis, graph for the motion of the train from A to E, right? So the whole journey, they use the acceleration calculated in question 6.5 and the information provided on your graph, right? So I'm going to scroll down to find my graph there, and then we try and plot, right? So it means here, according to our information there, I'm going to have, we are told your acceleration should be on this other end there. So A in meters per square second, meters per square second. So acceleration in meters per square second. A in terms of acceleration there, and then bracket meters per square second. So that's what you're having there. According to this is my acceleration time graph. So it's going to be my acceleration versus time graph. Okay, so this is what you're having then. Then after that, now we're supposed to look at the values that you're given, right? So there is the positive and the negative, right? So I can say from 0 until let me go back up there. From 0 to what? From 0 to what? Okay, so the maximum velocity was, okay, so this is the maximum acceleration that I'm having there, which is 0.33. So 0.33, so 0.33, so 0.33 there. I'm going to plot a value like let me just say here, from here, let me have my origin there. From there it's going to be 0 to 3. Okay, 0, 0. Let me have my origin there. And then after that, I'm going to like change this. Okay, so I'm going to say here, let's say I'm having my 0, 0.2, 0, 0.2, 0, 0.4, then 0, 0.6 like that. Then going down also, I'm going to have the same values there, which is a negative now 0, 0.2, 0, 0.4. It means I'm going to have a value of what? 0, 0.6 going in this direction, right? So there I'm going to have a line like that, then also populate it with what? With values there in terms of what? This is my time there, time in seconds, right? Therefore now, how much time did it actually take the total journey? Let's look at the time that it took the total journey there. So the total journey there is how many there until 14 minutes, right? So 14 minutes there means for me to convert that into seconds, I'm going to say 14 times 60. I'm going to get a value of 840. So 840. But okay, according to this, we asked to calculate, is it for the whole journey? From A to E. So let's me focus from A to E. Okay, so it's from here, this point here, until my E there, right? So this is my point E there, right? So it means it's for 6 minutes, right? So I'm going to say 6 multiplied by 60, which is a total of 360 seconds, right? So I'm going to get a value of 360 seconds. So let me just like scroll down there for 360 seconds, 360 seconds. Therefore, it means if I can say this first box there is 3, 6, 9, 12, 15, 18, 27. Okay. So for 36, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 6, right? 36. Let me see if I say 360 divided by 6, what am I going to get there? 60. So it means here I can say 60, 126, 12, 180, 24, then 240 there, which is then 360, then continuing like that, right? Then after that, now let's plot our values there. So our values there, in terms of the first part there, we got from A to B there. Remember, we got our acceleration to be 0.33, right? For B there, just to refer there, this is the answer that we got from A to B, which is 0.33. Then after that, the velocity, they went constant, therefore your acceleration is 0. Therefore, just let me just quickly do that there, right? So it means here I'm going to have a value of 0, 0.33, right? So it means 1, 0, 1, 2, 3, 4, 5, right? So it means somewhere there, then until that point there, which is seconds there. So let me check the time it took. It was minutes. It was how many minutes there? It was a minute, right? So it means it's going to be a milliseconds, 60 seconds, right? So it's going to be for 60 seconds there. So it means here, there, this is where I'm having there. I'm going to put that line there, right? So it's going to be from A to B. So this is my A to B, my first part there, which is A to B, like that. Then after that, now I'm going to say after that, what happened there to my velocity, it went what constant, right? Let me use a different color so that it's visible. Then after that, my acceleration went constant for until a point of what, of C there, right? C, I think until 180 or after 180. Therefore it's after 180. Therefore let me just like check to confirm the last parts, then we finish this graph. And then from C to D there is it's minutes. It's actually for B to C is 4, so it's 6, 12, 18, 24 until 24. Then there is a constant there. Okay, until 24. Then 24 they go down there, 24 until 24. Just to scroll down real quick there, 24, 24. So it's 2 until here. So it was constant for that period of time. Then after that it went down for CD, right? So it went down until a period of again 0.33. So it's 1, 2, 3, 4, 5. So in between there, somewhere there, right? So it's going to go down like that, dot line. Then here it's actually going to have to cross there, right? So to label my paths there, I'm going to say this is C to D, right? And then this is from B to C. This is from B until what, C. And then the top part there is A to what, to B, like that. Okay. So this is how we're supposed to attempt our paper there. With that being said, I hope you did enjoy the paper. Thank you for watching.